In progress.
Okay, so now we're going to the notes for today. So sorry that I had to explain what you guys did Friday. So how are circles and sine graphs connected? Jimmy, can you read that first paragraph? Which is throughout this course. Okay.
Throughout this course, you have used multiple. Yeah.
Yeah, keep going.
Course, you have used multiple representations, solve problems and create functions and justify conclusions. In lessons 7-1-2, we found a unit circle in one representation of a sine function. Today, you will investigate the connection between the unit circle and its graph. As you go deeper understanding of the sine function.
Okay, thank you, Jimmy. So let me show you the unit circle. We're going to talk about that in great detail in less than 7.6 next week. We'll talk more about the unit circle. And the unit circle is going to be something you're going to see often in pre-calculus. In fact, actually, you spend about 3 months on trig in pre-calculus. It's a big part of the class. So we're only doing a little bit in this class. So yeah, so get ready for that. Let me show you the unit circle looks. I'm not going to expect to fully memorize it. I don't think we did last year. You will need to in pre-calculus though. But let me show you how it looks. So this is the unit circle. And it looks a little crazy.
We have to memorize that next
year? Not for this class, but not fully in this class, but
next year.
Yes, but it's not hard. Once you get the hang of it. So notice. Yeah, yes, exactly. Yes. That's why it's not that bad. First of all, where's your center? Where no, the center. What coordinates are the center? The coordinates. 0, 0, the origin. How long is the radius? 1. Perfect. That's why it's called a unit circle. It's the most basic circle you can make. A center of 0, 0, radius 1. I'll provide this for you guys probably tomorrow. And when you go clockwise, sorry, that's counterclockwise. I should know how the clock works. You go counterclockwise. We go counterclockwise. That's considered the positive direction. So notice that 30 degrees is over here. And look over here, √3/2, 1/2. Where did that come from? It came from a 30-60-90 triangle. How long is my radius? 1. That's 30 degrees. So the height would be what then? How's the height compared to the
Root?
It's 1/2. It's half. Yeah, exactly. It has to be half the hypotenuse, and this is √3 times the leg. No. Because it's going from like that. It's not really short. That's what's a little short. It's like 28 something. So what's happening is that you're drawing something like this here, and you do this repeatedly all the way through. Now, the pi over 6, where does that come from? If you think about that, what's half a circle in degrees? 180, right? If you do a 180, it means you turn around. Like we know that in our everyday language. Well, that's pi radians. We did that distinction last week. Pi radians equals 180, right? Now, if you use proportional reasoning, it's not that hard. If you use proportional reasoning, 30 is what fraction of 180?
1/6.
So wouldn't pi over 6 naturally be the radians? Because you take 1/6 of pi, right? Okay, look at 90. 90 is what fraction of 180? That's why you have pi over 2. Look at 45. 45 is what fraction of 90? What's half of half? A fourth, exactly. That's why you get pi over 4. And you kind of repeat this all the way through. I'll talk more about this next week. Like, look at 120. 120, is that double 60? So what's double pi over 3? 2 pi over 3. So you don't really have to memorize. That's why I feel like I have to, like, they try to, okay, which one's in the third quadrant? Is it 5 pi over 4? Is it 5 pi over 6? They get all confused. No, just use proportional reasoning. Know the first quadrant. 30, 45, 60 seems pretty obvious. Know the ratios. It's not that bad. Also, look at these other coordinates here. Isn't that the same as this? The only difference is that x is negative. Of course, x is negative. You're in the second quadrant. Y would be positive. So it's not that bad if you get the hang of it. Why do we have this? We have this because if you think about it, if that's 1 and that's x and that's y, I'm going to talk about this in just a moment. Wouldn't sine theta be y over 1? Right?
Yeah.
Isn't the y coordinate here 1/2? Sine 30 is 1/2. right? Think about the cosine. Isn't the cosine adjacent of hypotenuse? Is my adjacent x my hypotenuse 1? If you were to measure that, that'd be root 3 over 2. Look at the x-coordinate. That's root 3 over 2. So we start seeing how this helps us figure out all these trig functions. So the x corresponds to cosine, the y corresponds to sine. By the way, tangent. Isn't tangent opposite or adjacent? What's my opposite here?
Y.
What's my adjacent? X. Tangent will be y over x. So for example, you are going to do this. Say ask you for tangent 210 degrees. What's that going to equal? It's going to equal y over x. So I divide those together, and that'd be my answer. We'll do this stuff later. Actually, I think we do this in more detail in the next unit, because I think we still do more trig in the next unit. But that's what we're working our way towards. So that's what's being mentioned over here. About a unit circle. It's a circle with a radius of 1 unit, center at the origin. Periodic function, a function repeats itself. We saw that with sine. Appears defined as the range of x values to complete 1 cycle. So how can you graph 2 periods of the sine function in the calculator? You go to y equals sine x. You go to window. You make your x min 0. You make your x max 360. So you might, sorry, 720. My bad. And mode, these b's degrees. Mode's gonna be degree. That's how you do it. We will talk about graphing radians. For now, let's keep in degrees just to keep things simple. So not too much notes here, just more explanation. That makes sense, hopefully. Here it says Henry Oliver make it home, unhurt, but need a shower. After they cleaned up, okay, this story's dumb. Let's keep going. They draw a picture of the Ferris wheel and 5 of the seats. So they draw these 5 different positions. Don't worry about the yellow paper. I'm not going to do that. Let's not worry about that either. Let me just do a quick drawing for part B, just so you know what's happening. Can I move the screen?
Yeah.
Okay. So it says here draw 5 new triangles to the first 5 that are connected to the first 5 are looking in the second quadrant. So what they really want you to do is this. Here's the ride, right? Yeah, that's 15 degrees. I'm not gonna draw 5 because it's gonna get a little too messy. And that was 100, right? And that was my height. What if I wanted the same position in the second quadrant? How would that look? That'd be over here, right? That's still 100. That's still h. What would we measure this angle right here? Still 15, right? However, if I want to draw the angle like this, so essentially I'm doing this. Hey, you don't have it? Oh, I thought I handed it to you.
So you handed me a packet or something. It was just an over.
Yeah, yeah, the solution. I'll check your stuff again. What would be the measure of that angle? It's going from the positive x-axis. Right, x would be negative, right? Y would be positive. But this angle that I just drew right here, we call this an angle in standard form. How far have I traveled around the circle for that second diagram I just drew?
90.
So it's not quite 180. 165, right? And that's something that you guys are gonna start talking a lot about, like how to look at angles, not just from 0 to 90, but from 0 to 360. So even though that's 15 degrees for the base angle, it's truly 165 degrees when you think about it in terms of sine and cosine. and the position it's in the quadrant. So they say here, label these with their angle measures. So that angle measures 165. So 165 corresponds with 15 degrees. Now, the problem is asking to do this 4 more times for 30, 45, 60, and 75. I'm not going to do that. I think that's just redundant. But I think you guys get the point that, okay, if I go 15 degrees in the first quadrant, what would be equivalent to in the second quadrant? 165, because they share the same base angle. So that means that their heights are going to be the same, right? The heights off the ground. Their sine values will be the same also. If I go to a calculator and punch it in, if I do the sine of 15 degrees, I get some wacky number. If I do the sine of 165, I get the same thing, as you should. You should get the same thing. And that's because you're forming a 15-degree angle with the x-axis just on the other side. That's all. So if you want to do it for the third and fourth quadrants, let's do it again. Let's go to the next page. If I do it for the third and fourth quadrants, it'll look like this. I'll do a quick diagram here. Hypotenuse is still 100. Now, the height values, are those going to be positive or negative? Yeah, height is now negative. So that's all that's happening. Now, in terms of the angles, how would I call this? What would I call this angle right here in blue? Because it's half rotation plus 15. So it'd be 195 degrees, right? How about this one here? I'll do this in black. Again, that's 15 degrees right here, right? But if I rotate from the positive x-axis, go counterclockwise, how far have I rotated in red?
345.
Yeah, good. Good. You guys getting it. Perfect. Good. So this is teaching you standard position or standard form for an angle. So that's what's happening. Let's skip 730. I don't think we need to do 730, I think we can skip that. I think you guys kind of get the idea here. So let's just move on to 734 and wrap this up. And you guys can do the homework. It's almost done here. Let's see. Okay. So let's say, for example, you want use your graph from earlier to find the height of the seat that's rotating 130 degrees. Okay, so let's work that out. So 130 degrees will look like this, right? So tell me when I should stop when I travel 130. Around here, yeah, that makes sense, right? That's 130 degrees. Now, if you think about it, what's the measure of this angle right here? What would that be, would you say? Close, 50. Because you got to go to 180, right? So if I draw that again, that's 100. That's 50 degrees. How would I solve for the height? What would I do? Yeah, 100%. Yeah, totally. So sine 50 degrees equals what over what? Well, h over 100. So we're not using the unit circle right now. We're just looking at the actual situation. Right, the unit circle, I look at the y coordinate. That's what I do, but because of height, because of radius is 1.
Why did it change from 130 to 100?
No. 130 is the angle, 100 is the length of the hypotenuse. So
Plus 130?
no. I'm gonna do 180 minus 130. Because I saw it 50 short. So, where'd my calculator go? Oh, there it is. Okay. So if I do that, 100 sine 50, you get 76.6 feet. So that's how high they were off the ground. 76.6 feet. Now, you could also have done this. Hundred times sine 130 degrees is the same thing. It'll be the same exact thing. So when I ask you, calculate angles that correspond to C's of the same height, that's gonna be 50 degrees. And we call this the reference angle. We'll talk about that thing later in the week. Because a reference angle is always going to be acute. You guys remember what acute means? Yeah, between 0 and 90. So it refers to 50 degrees because it's going to be very similar. 130 and 50 are going to be the same thing. And we see that between 30 and 150, by the way. If you look at 30 and 150, because don't 30 and 150 apt to 180, right? So as long as the two angles apt to 180, the sine values will be the same. Like sine of 110 equals sine of 70 degrees. So that should be pretty straightforward. So the last bit's asking us to find the heights and find another angle the same height, sketch, whatever. So let's do that for these last three, and then you guys can work on homework. Yes, go. Yeah. I don't care. Don't worry about it. That's semantics. Don't worry about that. So this one here. Here's what we're gonna do. I'll be really quick. I'm gonna draw 3 coordinate planes.
Which one was this? Oh yeah, I see it.
Yeah, we skipped the other one. Okay, so let's draw each of these angles. So you're going to always draw it from the positive x-axis, go counterclockwise. Two hundreds like that. And 310 would look like this. Let me draw this one just a little bit better. That's what I meant to say. I meant to do that. My bad. So that's 80 degrees. 200 degrees. It always stops at the hypotenuse.
Why stopping? Like,
For which one? So 80, you want to rotate 80 degrees. So you almost do a quarter turn. You stop a little short, right? Because a quarter turn is 90 degrees. 200, you do a half turn and a little bit more. 310, you do a 3/4 turn and a bit more. Because 3/4 turn is 270. So, and what's the question asking again? The question asking us to find the height. Okay, got it. So again, let's use 100 as our radius. So let's go different color. Go blue. So somewhat patriotic colors. There we go. So if I want to solve for the height in each case, so the height again is going to be this. The height's going to be the radius times the sine of the angle. Because this is the sine of the angle height over the radius, right? Wouldn't the sine be h over r, right? So sine theta or y over r. Think like that. That's actually the more proper way to think about y over r, right? That's really what it is. So just punch my calculator and just do it over and over again. So if I take my radius times the sine, 100 sine 80, that's about 98.5 feet. That sounds about right. Because you're close to the highest point, right? Now this one's gonna be negative. If I do 100 sine 200, now you have to actually use the real angle because you have to get the negative values. So even though I could have done 20 degrees, but I have to make it negative, right? So you have this reference angle is 20 degrees, but I have to use the actual rotation. And this one here, if I do 100 sine 310, I get negative 76.6. And if I want to find similar locations, what will be similar to this? Probably 100 degrees would be similar to this. 340 would be similar to this. And I think 230. I think I got that. I know it's kind of weird. I think I got that. Okay, 200 is how far off from the x-axis? 20, right? How far off, if you're on the other side, if you're 20 off, what would you be at? 340. 310 is how far off from the x-axis? 50, right? I messed up. No wonder you guys confused. That's not 230, guys. I messed up. What should that be? Oh, you're right. I was right. I didn't mess up. Sorry. See, I'm getting confused. I did 40 away from here, so 40 away is 250, or 50 away from here is 310. So 50 away on this side would have to be 230. My bad. Yeah, I got it.
So there's multiple answers.
Yeah, 100%. And by the way, you don't have, there's infinite answers actually. What if I add 360 to this? What if I put 670 degrees and 690 degrees? Or is that right? If I add 360. Oh, 590, right? By the way,
So you're basically subtracting 20 from the closest x-axis.
yeah, because let's say you go on this ride many times. You go many times, it's cyclical, it repeats itself. So we'll talk about that as well. Like you could totally have infinite possibilities here. 180. It would be positive though, not negative. That's the only thing. Right, exactly. We want it to be right, the same sign, right? Good. Okay, so I think we're all set. This is great. I know it took a little while, but you guys need it. You guys have the homework pack. I guess when you get start, you can. You got oh, we're gonna have a quiz tomorrow. We're gonna start doing quizzes more often. So yeah, there's three quizzes in a row, Wednesday, Friday, and next Tuesday. Will be short questions, very straightforward on this stuff. Yes, very. Next Friday, the 28th.
2 Fridays from now.
2 Fridays from now. Yes. All right. I'll go and stop there.